Okay, so how is everyone today?
Great.
Good? All right. The exam is Monday night. Good. And then a little later this afternoon, the keys will be revealed, and the room in which you're taking the exam will be revealed. That'll be a grade in the grade book. So, be sure and look at that and figure out where the room is. All right. So today's the 12th, and we've been talking about functions. So we still have plenty of stuff to say about functions. So notably, the mental model that I'd like for you to have for functions, so the mental model, is that it's like a machine where you give it inputs and it produces outputs. So it's a machine in the sense that every time you give it the same input, the same output is generated. It's purely deterministic. It always does the same thing. The set of all inputs is called the domain. So inputs are from the domain. And the machine will generate an output. So outputs from the range, and notably, for every input, there's exactly one output. All right, so an example would be something like, I could say, let f of x be the function 5 x squared plus 8. So there's a nice function. In the first place, I could say, well, would you please evaluate f at 4? So what is being requested? Yeah, to replace all the x's with 4's. So that'd be 5 and then multiplied by 4 squared and then plus 8. All right. So then, that'd be 16 times 5 is 80 plus an 8 is an 88. Here's something interesting. What about f evaluated at -3? So now what's being asked? Right, same thing except plug in -3. So I'll write this. So have I written it correctly? Right. You've got to put parentheses around the -3 now. Why is that?
Is the whole thing squared, not just the 3?
Right, because observe what the recipe, what the rule is for an input. It's saying, well, first you square the input, and then you multiply by 5, and then you add 8. So that's what you're supposed to do. But what's currently written, according to the order of operations, we're not squaring -3. Rather, we're squaring 3 and then negating it. So as written right there, that's -9. Okay, so to make it right, like that. So now it's right. So 9 times 5 is 45. 8 more is 53. And then we could do something like, well, what about f of I don't know, a plus 6? Well, again, so that'd be 5 multiplied by a plus 6 all squared, and then add 8. And you know, the instructions for something like this would say, you know, multiply out and collect like terms and what have you. So this would be 5 multiplied by a squared plus 12a plus 36, and then add 8. So I did FOIL in my head there for that. And then now I'll distribute and get 5a squared plus 60a plus 180 plus 8. So 5a squared plus 60a plus 188. Any question about this one? So one thing I want to point out is that notice for request number 2 and request number 3 that you needed to put parentheses around what was substituted in the formula. But you didn't have to do it for request number 1. Now here's the deal. Generally, when you're substituting something into a formula, like you're going to substitute something in, you can always put parentheses around it. That will always be correct. And even some of the time, it'll be correct to not write the parentheses. But here's the deal, is that if you're not sure of the distinction, then you need to always put parentheses. You need to always do it. Because it's always correct to do it, and some of the time it's correct. It's this okay not to. But that's kind of a hard lesson to learn, because you know, if you ever take a psychology class or anything about that, you learn something about conditioned behavior and things like that. And there's such a thing as a Skinner box, which basically says that if there's an action that some of the time works, then it's very hard to get the test subject to stop doing it. So what I mean is that some of the time it's going to work to leave the parentheses off. But I'm just telling you, behaviorally speaking, it's hard. It's going to be hard for me to say, go ahead and put the parentheses, and for you to do it. Good. Any question about this? All right. So then now, this part of the mental model, and you know, for that matter, sort of definition of function, exactly one output. I want to. I think we said this at the end of last time, but I want to remind you of something. Is that if I say let h of w be the square root of w, meaning that we're interpreting h of w. So h is a function whose input is w, and we're considering the square root. And at the beginning of the course, I asked something like, well, what about this? Which is to say, you know, what's the square root of 49? So what's the answer? 7. And then at that time, some of y'all said positive or negative 7. And no, that's not right. And the answer is not negative 7 either. So in some sense, well, the answer is 7. But some of y'all said positive or negative 7, and that's even worse. Why is that even worse according to the definition of a function? Why is that even worse?
Because it can only have one output.
Right. It's a function is a machine that's permitted to have one output. So if you say something like the square root of 49 is positive or negative 7, what that's saying is that you don't understand that a function must have exactly one output. You're saying that, well, this one has 2. But there's a different matter. Now, is it the case that 7 and negative 7 both square to 49? Is that true? Yeah, but that's not the same thing, because that's running the machine in reverse. So what I mean to say is that if here is 49, and we're going to say what the square root does. then how many arrows are allowed to leave 49? One. That's it. There can't be another one. Otherwise, it wouldn't be a function. But if you turn the machine around, then and you're going that way, then that's not called square root. That's called squaring, right? And squaring is also a function. How many arrows are permitted to leave -7? 1, and it hits 49. How many arrows are permitted to leave 7? 1, and it also hits 49. And that's fine. So can you see the distinction? The square root of 49 is 7, not positive or -7. Good. So now let's specifically consider square root closely. So let h of w, now I'll say x on this page, doesn't matter. Let h of x be square root x. So my first question is that what is the domain of h?
Greater than or equal to 0.
Right. It's that's equivalent to asking, well, what x's could you plug into that square root? You know, we've talked about that all semester. The answer is that x has to be greater or equal to 0. And then as an interval, you could write it like that. And as a picture, you could, as a plot, you could draw it like that. Okay, now, a function is a machine that takes inputs and produces outputs. The inputs come from the domain. Where do the outputs come from?
Range.
The range. So another question, another thing that I want to be able to say about square root is, what is its range? Now this one is a little bit harder to see. So before I ask the question, what is the range of the square root, we're going to make a sketch. Specifically, we're going to sketch y is h of x. So to that end, I'll make a table here. So x, h of x. So I want to do all these. So 0, 1, 2, 3, 4, 5, say. So what's the square root of 0? 0. Square root of 1 is 1. Square root of 2 as a decimal is approximately what? It's about 1.4-ish. 1.41. But I'm plotting it, right? So I can't plot that accurate. So the square root of 3 is about 1.7. What's the square root of 2? About? I mean the square root of, darn. The square root of 4, what is it? 2, right? Haha. Okay, so then what about the square root of 5?
2.5.
Yeah, so about, according to my calculator there, it's about 2.2. Okay, so let's plot that. Okay, so 0, 0, 1, 1, 2, 1.4, 3, 1.7, 4, 2, 5, 2.2, so something like that. So there, we plotted 6 points. If we had plotted, many more points, then it would look like this. something like that. All right. So that's a sketch of what it looks like. Why is there no plot on the left side of the thing?
The domain is greater than or equal to 0.
Right. That's what the domain is saying. The domain, the inputs must be greater or equal to 0. And then where the picture is concerned, that means that the plot has to be on the right side, because that's the part where x is greater or equal to 0. So there's nothing over here. So ignoring that this is square root for a moment, ignoring that, I can ask the following question. I can say, okay, right there I'm pointing at like negative 3.5. X is negative 3.5. And I have this vertical line there. Now, is this vertical line that I have there, is it touching the plot at all?
No.
It isn't. That means that negative 3.5 is not part of the domain. It's not part of it. How about negative 2? Is that part of the domain?
No.
No. So the way that you can tell the domain is that you either literally, like I'm doing, or figuratively, take a vertical line and then sweep it to the right and ask, when am I hitting the plot? So right now it's no. So I'll say do 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 do. Oh, that's where I'm hitting it. You see where I'm hitting it right there? And then, for example, right there I'm hitting it. So that is 1.5. X is 1.5. Do you see that I've got a red point there?
Mm-hmm.
So notice that from now on I'm going to hit the plot. That's what it means for the domain to be x greater than or equal to 0. Okay. Alternatively, if you can imagine, the following is that I take this and suppose that this plot is covered in paint. It's like covered in red paint, and then I take it and I squish it and go squish it onto the horizontal axis, like that. What part of the axis would be painted? Can you see it would be just that much? Even more alternatively, suppose I put a light source up here that's infinitely far away, but nevertheless shining very brightly. Do you see the shadow that would be cast onto the horizontal axis by the plot? So all of those things are the same thing. That's this. This is the part that would be painted, or if you like, that's the part that would cast the shadow, or if you like, those are all the points that where this vertical line touches the graph. This is the domain. So the reason why I say that is because now I want to ask a similar question. I want to ask, what's the range? And that question is the same question, except you just turn your head sideways. So now instead of making vertical lines, instead of asking about vertical lines, now we're going to ask about horizontal lines. So, for example, that's the y value -4 that I'm pointing to there, and that's the corresponding horizontal line. Am I touching the plot? No. So that means that -4 is not part of the range. It's not part of the range. Similarly, that value is not part of the range, and none of this stuff down here is, right? So then, now we need to sweep upward and ask, when do we start hitting the red points? So do 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 do. Oh, I'm hitting them, right? So now I've hit it. So you can see, like for example, that point right there. That point right there, is it part of the range?
Mm-hmm.
Yes, because that horizontal line is touching the plot. Okay. Alternatively, again, we could say, well, suppose we paint the plot, and then now instead of squishing it like this, so we squish it like this. So squish onto the vertical axis. Like that. Or, if you like, imagine a bright light is over here, and it's shining, it's infinitely far away, but it's shining quite brightly. Can you see the shadow that would be cast on the vertical axis? So the question sort of just becomes, how far up does the square root end up going? All the way up, right? So for example, the square root of 100 is 10. The square root of 1 million squared is a million. The square root of a billion squared is a billion, right? So it goes all the way up, right? So, you know, one way or another, you know, squishing it, casting a shadow, whatever you like, all of this is the set of all outputs right there. So that's the range. Okay, so then written with inequalities, you could say, since we said, you know, we're calling this y as h of x, the range is going to be y greater or equal to 0. Written as an interval, like this, and then plotted like this. So why like that?
This is the y-axis.
Yeah, because we're talking about a subset of the vertical axis. Any question about this one? All right. Similarly, so that was square root. Let's look at cube root. So we'll consider, how about, I'll say let q of x be the cube root of x. Now, the question is, well, what about, what's the domain of q?
All reals.
All reals now. Because remember that radicals have, their behavior is strongly influenced by their parity, by the parity of their radical number. Which is to say that because this is third radical, and because 3 is odd, that means that it has the odd behavior. And the domain is going to be all reals. So negative infinity less than x less than infinity, which is to say everything. Everything. Similarly, we want to make, we also want to consider the range, but before that, I'm going to make a sketch. So a sketch of y is q of x. So again, a table. Now, because on the square root's only defined for non-negative x's, I started at 0, but negatives can be input, so I'm going to start at negative 5. So negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. All right. So the cube root of 0 is 0. The cube root of 1 is 1. And now, you know, I've run out of knowledge there, so now I need to use the calculator. How do I get the calculator to compute the cube root of 2? How do you do that? So what you have to type is you type 2 and then caret in parentheses 1/3. That's how you get it to do that. If you have a different calculator, it might be something slightly different. So 2 caret 1/3. So that's about you know, 1.25, say. Not trying to be exact here. So that, you know, that's just an approximation. And then cube root of 3. Oops. That's about 1.4-ish. Cube root of 4, that's about 1.6. And cube root of 5, that's about 1.7. All right. So then now, for the negative ones, I claim that you should be able to do those without the aid of any more calculator. How do you do that?
It's just the negatives of what we found.
Right. It'll be the same as all these, except negated. So negative 1, negative 1.25, negative 1.4, negative 1.6, negative 1.7. Okay, so then plotting that. So 0, 0, 1, 1, 2, 1.25, 3, 1.4, 4, 1.6, 5, 1.7. All right, so something like that. You draw big dots so that, you know. Okay, good. And then going the other way, you know, there's a kind of a symmetry, but it'll be going down. So then that, and then 1.25. Okay, so then there's several of them. If we plotted even more points, then it would end up looking like this. Something like that. So it is in some ways similar to the square root, at least on the right side. So if you ignore the left side and just look at the right sides, they look pretty similar. But you know, the cube root is defined on both sides. So why is it defined on both sides?
Because it's obvious.
Yeah, that's what the domain is saying. It's saying it's defined on, when you look at its picture, it's defined on both sides. Okay, so again, if suppose that it's painted, and then we take it and then vertically collapse it like this and squish, what part of the horizontal axis would be painted?
All of it.
All of it, right? So it's all going to get painted there. So that whole thing is the domain. And then what if we squish it like this and let it collapse to the vertical axis? Then what gets painted? All of it. Because you know, it goes up pretty slowly, but it does go all the way up. Because, for example, what's the cube root of 8? 2. And then what if I take 1,000 and cube that, and I have no idea what that is, but then I compute the cube root of that? What's that? 1,000, right? And what if I take a you know, what if I take a trillion and cube it? What's the cube root of a trillion cubed? A trillion, right? So then we can go as far up as we care to go. So the whole thing, the whole vertical axis, is the range. Everything is reachable. So negative infinity less than y less than infinity, which is, could be written like this. You know, so could be drawn like that. So the whole thing. Any question about this one? All right. Good. What about, so we drew the square root. We drew the square root 2 pages ago. So now, so in some sense, its counterpart is the squaring function. Let's draw it. So I could say let s of x be x squared. The function which takes its input and then just, you know, squares it. So what's the domain? All reals, right? Because the question is you know, for which x? For which x's is that defined? All of them, right? So all of them. we'll make a sketch. So let's see. I'll think about it for just a second here. How about I'll do -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, so then squaring 0, you get 1. 1 squared is 1. 2 squared is 4, and then 9, and then 16. So then I claim that the negative ones are easy. What are they?
The same as negative.
Right, the same as these. But they'll still be the positive ones, right? Because the squaring gets rid of the negative. So notice that this sequence of numbers is read the same top to bottom and bottom to top. So it's read the same backwards and forwards. Such things are called palindromes, like race car and taco cat, and mom and dad and other things. So that symmetry is going to show up. In the picture. All right, so then because the numbers are a little big there, I'm going to say that the big tick marks are 2, and the little ones are 1. So I can hopefully get a bunch of points on there. So we'd have 0, 0, 1, 1, 2, 4, 3, 9. And then 4, 16 is, you know, way up there. Okay, and then you know that's the bottom half of the table, and then the top half is you know, because it reads the same forwards and backwards. What's going to happen is that these points will be just reflected over. Something like that. Something like that. So the name of that shape is parabola. Good. So then again, concerning the horizontal axis, suppose we paint the parabola. It's covered in paint, and then squash it to the horizontal axis. What part of the horizontal axis will get painted?
All of it.
All of it, right? That's what it means to say that the domain is that. And then if we squish it to the vertical axis, squish it like that, then what part of the vertical axis gets painted?
The positive.
Just that bit, right? So nothing down here gets painted. Alternatively, if you like the lines bit, then you can say, well, is this point right here in the range? And the answer is no, because this horizontal line is not touching the plot. So nothing down here is touching the plot, so none of this down here is in the range. The range starts right there at y0. So the range is y greater or equal to 0, which could be written like that, which could be drawn like that. Interesting. So notice, for example, that that's 2, and that's -2. Notice that 2 squares to 4, right? 2 squares to 4. And -2 also squares to 4. Now, looking at the square root, oops, you can see that their shapes are similar. Like if I turn it like this, right? But the square root kind of only has like one side of it instead of both sides. And we're going to have to see, we're going to get more into that, but have a look at, and observe that the square root is kind of like a parabola, when you turn it, but it's only got one side. So that one-sidedness, is part of the reason why. Well, in the end, you observe things like if you square something and then compute its square root, then what you'll have is the absolute value of that thing. So the square root of x squared is absolute value of x. So the fact that square root has just one side is what causes a problem. So I'm going to just very quickly sketch one more, just so you can see it in your mind the next time we draw it on Monday. If we say let r of x be 1 over x, r for reciprocal. There's nothing special about these names as far as that. It can be anything. What's the domain?
Can't be 0.
Yeah, anything except 0. And then let's make a sketch. Well, this is a little tricky. So if I say something like 1, 2, 3, 4, those are easy enough. So like if this is x and this is r of x, then here the output is 1. The output would be half, a third, a fourth, right? But what if I say, what about input half? Then what's the output? 2, right? Because what this function does is it computes the reciprocal of its input. So what's the reciprocal of 2? What's the reciprocal of half? It's 2. And then if I input a third, then out will come
3.
a 3. And if I input a fourth, out comes 4. And if I input 1 over 1,000, then out comes 1,000. And then I could reproduce all of that, but with negatives. So as a result, here's what the sketch of this one looks like. One, 1, 2 half, 3 a third, 4 a fourth, half 2, a third 3, a fourth 4, etc. So just that stuff that, except 1,000, right? I can't fit that one. So like that. And then if you do the negatives, you'll also notice that you get these ones that include that one. So it will look like this. And that shape is so important that it has a name. We'll talk about its name on Monday, but it's for now its name is hyperbola. All right, let's have a quiz.
It's just the sign chart. New word this week. Yeah. I thought we must